We are going to solve the independence practice that is in your book of instruction in Ready Math. So in this case, I have 6 problems that we are going to solve. Problem number 1 says, which expression is equivalent to -4 to the -5th power to the 0? It's a power of a power. You have different steps to solve that problem. It's up to you again. Okay? It's up to you. So far, I can tell you right now that the solution is A. Okay? The solution is A. How do we get there? Okay? Number 1, we are going to do 2 steps. So look at the first one. So I have -4 to the -5th power to the 0. I don't need to do any step. I know that if you have n to the 0 power is equals to 1. So all this expression is to the 0 power. So my solution is 1, just using that property. So the answer is A. What is another step? Okay, so second step. So if you have -4 to the -5th power to the 0, okay, remember the property that you have n to the a to the b power is equals to n a times b, okay? So where is -5 times 0? So this is equals to -4, okay? -5 times 0 is 0. And -4 to the 0 is equals to 1. Same solution, but I apply a different property. Okay? So we get the same solution, but doing 2 steps, which is practically the same. So let's do number 2 now. Which expression is equivalent to 7 to the 2nd power to the 5th power, and then I have 7 to the -6th power. Okay, so let's work this problem. So I have 7 to the 2nd power to the 5th power over 7 to the -6th power. Okay, here I have a power of a power. Okay, so you have here, I'm going to write it here, n to the a to the b is equals to n a times b. So it's equals to 7, 2 times 5 is equals to 10. Okay, over 7 to the -6th power. 2 options. 2 options to solve this problem. So option number 1. We move this 7 to the -6 to the numerator, and we're going to change the negative exponent to positive. So this is what's going to happen. 7 to the 10th power times 7 to the 6th power. So I have negative exponent, but if I move it to the numerator, I'm going to have a positive. So I have 2 bases, similar, 7, okay? So I have 7, 10 plus 6 equals to 7 to the 16th power. So which one is the right answer? Is D. Okay. What is the other way to solve this problem? So I'm going to do it from here. So I have 7 to the 10th power over 7 to the -6th power. Okay? So if I do division, for example, NA over NB equals to NA minus B, we need to be careful with this negative. So it's up to you which step you're going to choose. So I have 7, same base, 10 minus, this minus is from the formula, and then I have -6. So it's equals to 7. Negative and negative is positive, so 10 plus 6 equals to 7 to the 16th power. So I have exactly the same solution. exactly the same solution. Two different steps. Is up to you which step you're going to choose. Step number 3, problem number 3. Which expression is equivalent to 1 over 49? Select all that apply. Select all that apply. Okay, so in this case, I have 1 over 49. I know 49 is 7 times 7, okay, from multiplication tables. So I know 49 is equals to 1 over 7 times 7. If I don't have an exponent, that means it's 1. Okay? So look at this one. If I move these two to the numerator, I will have 7 to the negative 1 times 7 to the negative 1, just by move these two to the numerator. If it's positive, if it moves position, it changes the exponent from one sign to another one. So in this case, it's positive, it's going to be negative. So A is the first answer. A. Okay, I'm going to forget about this one. So I have 1 over 7 times 7. Okay? So what will be the next one? Okay, so I have 7 and 7 is equals to 1 over 7 to the second power. Let's look at the solutions. I have 8 and negative 6. There is no way that one is going to be. It has to be the difference of 2. So what is negative 5 plus 3? Is negative 2. Negative 5 plus 3 is negative 2. So what happened? If I move this power to the numerator, I have 7 to the negative second power. So C will be a solution, because negative 5 times 7 to the negative 5 times 7 to the third power is equals to 7 to the negative 2. Same base, negative 5 times 3, negative 2. What else? 7 minus 2. 7 minus 9 is equals to negative 2. Also D. 7 here. I'm going to do it here. 7 to the 7 power times 7 to the negative 9 is equals to 7. 7 minus 9 equals to 7 to the negative 2. Same solution, different approach. And now look at E. I have negative 2 and 4. So if I simplify this one, negative 2 plus 4 is equals to 7 to the second power. It's negative 2. It's second power if it's in the denominator. But this one is not in the denominator. It's in the numerator. So the only solutions are A, B, A, C, and D. Okay, so let's do number 4. It says, write 16 to the 8th power as a power with base 4. Okay, with base 4. So what I'm going to do, okay, I know 16. You need to know your factors here. 16 is 4 times 4. So I'm going to have 16 to the 8th power is equals to 4 times 4 to the 8th power. If I have 4 times 4, is equals to 4 to the second power to the 8th power. Remember the property, if you have n to the a to the b, is equals to n a times b. So in this case, I have 4, 2 times a equals to 4 to the 16. And that will be the solution. So look all these steps just by using the exponent properties. Okay, so that's page number 10. We have one last one, page number 11. Okay, page 11. I have number 5. Look at the equations below. Choose true or false for each equation. Choose true or false for each equation. So I have 2 to the 4th power times 3 to the 4th power equals to 4 to the 6th power. Okay, the exponents are the same. So I'm going to write it here. So I have 2 to the 4 times 3 to the 4. Exponents are the same. So I have 2 times 3 to the 4th power. So it's 6 to the 4th power. It's 4 to the 6th. They switch it. So in this case it's false. Let's do B. B, in this case, I have 5 to the 2nd power divided by 5 to the 3rd power. Is equals to 1 over 5. Okay, let's do it. So I have 5 to the 2nd power divided by 5 to the 3rd power. Is division. How can I write that division? This one is the same as having 5 to the 2nd power over 5 to the 3rd power equals 2. Okay, so I have bases are the same. So I have 5, 2 minus 3 equals to 5 to the negative 1. And I don't need the negative exponent, so I need to 1 over 5. So it moves to the denominator. Now in this case, 1/5. So this one is true. Then I have C. 6 to the 3rd power to the 4th power is equals to 6 to the 4th power to the 3rd power. We solved one example similar to this one, and this one is true. That one is true. And then I have D. I have 3 to the 2nd power over 3 to the 7th power equals to 3 squared times 3 to the negative 7. This one is also true. Why? 3 to the 2nd power over 3 to the 7th power equals to 3 to the 2nd power times, if we move this one to numerator, 3 to the negative 7 power. So it's true. Okay. E. 8 to the 0 over 8 to the negative 4. So let me write it here. 8 to the 0 over 8 to the negative 4. If it's to the 0 power, it's 1. So I have 1 over 8 to the negative 4. If I move this one to the numerator, then we're going to have 1. Well, not 1, because this one is moving up. So I have a to the 4th power. That would be the solution, but I have a to the negative 4. So this one is false. It's a lie. Okay, F. So I have 4 to the 10th power divided by 4 to the 5th power equals to 4 to the 2nd power. So what I have, I'm going to do it here. 4 to the 10 divided by 4 to the 5th equals to 4 to the 2nd power. Okay, this one is the same as 4 to the 10 divided by 4 to the 5th power